So lead code problem of the day, and here we bring a solution for you. Welcome to the Runtime Error, the place where programming begins. In this video, we will be solving a lead code problem of the day, that is number of 1 bits. So this is one of the easiest question we are coming across today. So I highly recommend you to watch this video till end so that you can understand the approach and the intuition of this problem very clearly. So without wasting time, let's get started. So what does the question says that we need to write a function that takes a binary representation of unsigned integer. Now the question comes, what do you mean by unsigned integer? Unsigned integer itself says that a integer which is not a negative. Therefore, it simply means a number which is greater than 0. Greater than 0, it should not be less than 0. And what we need to do is we simply need to return how many number of ones are there in the binary representation of that unsigned integer, right? They have also given us one particular note. So what does it say is that in some programming languages like Java, there is no concept called as unsigned integer. So for that purpose, we need to use a to's complement so that we can get the unsigned integer. So I hope so you understood the meaning of the question. Now let's try to check what will be the sample input output for the problem. So this is the first sample input problems. They have given the n. Always remember, whatever the input we will be given, they will always be in terms of 32 bits, right? They will be always be in terms of 32 bits. So if you count the total number of bits present in this n, they are 32 bits. And what will be the final output? 1, 2, 3. So in this whole number of bits, there are 3 ones present. Therefore, my output will be 3. If you take this n, there is only one is present. Therefore, my output is 1. And if we count over here, there is 31 ones because there is only 1 0 which does not contain 1. Therefore, my output is 31. So I hope so you understood the meaning of the questions and the sample input output. Now let's jump to the proper approach and the intuition to solve this question. Now let's check the intuition for the question. So in this question, what they have told us, they have given us a binary representation of any of the number, and what we need to return is we need to return the number of ones. For in this example, there is only one, therefore we need to return 1. And there is one more problem that says that we have given a particular integer, say for example 6, and what we need to do is we need to return a total number of ones present in the binary representation of the 6. But in this problem, what they have told us, instead of giving a integer, they have given us binary representation, and we need to find the total number of 1 present in the binary representation. So can we say that the solution for this problem is somewhat similar to the problem which says that we have given an integer, find a total number of 1 in its binary representation. So both are the similar. So what we are going to do is we are going to use a concept called as a bit manipulation, right? Everyone knows it, I hope so. Bit manipulation. So how does a concept will look like? So there is one formula I have already told in the previous video, that is n equals to n and n minus 1. So the question comes, what does this showcases, right? What does this indicates? So what does this indicates? It simply removes last bit which is 1. For example, say for example n is equal to 6. Now what is the binary representation of 6? 2 raised to 0, that is 0, 2 raised to 1, 2 raised to 2, 0. I'm taking it 4 bits. And n minus 1, which is nothing but 5, right? This is 5. And what will be this binary representation? It would be 0, 1, 0, 1. And my original value of n is 6, which is the last 1 bit. This, right? This is my last 1 bit. This is my second last. So what does this indicate? It simply removes a last bit which is 1. So last bit which is 1 is this one. So this will remove a last bit. That is, it would become, if I do AND, it would become 0, 1, 0, 0. If we can see, previously my last 1 bit was 1 and it is completely removed and it is converted into the 0. So this is how n equals to n and n minus 1 work. It simply removes the last 1 bit. Now if you try to get the n is equal to, what does it indicate? 0, 1, 2, which means it is 4. And if I do n minus 1, which is equals to 3, and what will be the binary representation of 3? 0, 0, 1, 1. Again, if I try to do the AND, what would it be? 0, 0, 0, 0. If you look over here, the value of n is 4. The last bit 1 is this one, and we have completely removed this one and converted into the 0. Therefore, we have proved that n equals to n and n minus 1 simply removes the last 1 bit. And what does the question says that we need to calculate a total number of ones present in its binary representation, right? So I did this AND operation two times, 1 and 2. And how many number of ones was there in 6? 2, 1 and 2, right? Two times we have removed this. So can we say that we can implement this formula until and unless my n is not equal to 0. My n is not equal to 0. Once my n becomes 0, I need to stop, because that does not contain any number of ones. Therefore, we need to stop it. And at the same time, what we will do is we will calculate how many times we have performed the AND operation. How many times we have performed the AND operation. So let's take an example. Say for example, my n is equal to 6, right? So what I will do is I will run a loop till my n is greater than 0. Till my n is greater than 0. And what I will do is I will simply do n equals to n ending with n minus 1. And at the same time, I will keep the counter just to know how many times I am performing AND operation, right? So what I will do is cnt plus plus, and initially my count is equals to 0. So I will perform this operation, and at the end what I will do is I will simply return cnt. Now let's make a dry run to check whether this is correct or not. So we have seen that for n is equals to 6, what will be the binary representation? It would be 0, 1, 1, 0, right? And n minus 1 becomes 5, right? It becomes 5. So it would be 0, 1, 0, 1. Now if I do the AND operation, what would it be? It becomes 0, this becomes 0, 1 and 0. Which means again my last bit is converted into 0. And this will execute now because we have executed this one. So how many times we have performed the AND operation? Only one time, right? Previously it was 0, so it would become 1 because we have performed one AND operation. Still my n is greater than 0, so this condition becomes true. So what it would be? So n is equals to 4 now, right? This is 4. So it would be 0, 1, 0, 0. So n minus 1 becomes 3, which is equals to 0, 0, 1, 1. Now if I perform AND operation, it would be 0, 0, 0, 0. Now so n becomes 0. And again this will get executed, so it would become 1 of 2. Now simply I will return cnt, because why? See, my n becomes 0, so this condition gets false. So I will come out of loop and I will simply return cnt. Now what is the value of cnt? 2. And if I get what was the number of 1 present in the binary representation of 6, 2, 1 and 2. So can we say that we have finally got the required answer? We have finally got the required answer. So this is what we will be using to solve this question. It would be applicable for all the programming languages. So it was the most simplest question. Only a difference was in this question they have given a binary representation instead of giving us an integer. Even if they have given an integer, we would use the same formula. Whether they have given a binary representation or an integer, it is applicable to both. So don't need to worry about it. So I hope so you understood the intuition and the approach to solve this problem. Now it's time to see what will be the C++ and the Java code. So this is the C++ code and this is the Java code. You can check according to your own convenience. So as I told you, first of all, I will keep the counter to count total number of AND operation we are performing. So for that purpose, I have maintained the variable called as ANS. Similarly, I have maintained here ANS. So what we'll be doing, I will be running a loop till my n is greater than 0. And at the same time, I am performing n equals to n and n minus 1. And I'm also keeping the counter just to make sure how many times I am performing AND operation. And once my n becomes less than 0 or equal to 0, I will simply come out of my loop. And what I will do be, it will simply return a total number of AND operation we have performed, which is nothing but total number of ones present in my binary representation. Now if I talk about the time complexity, can we say that my time complexity will always equal to big O of number of ones. So this would be my time complexity, because if I have the 4 1 in binary representation, it will loop till 4 times. If I have the 6 ones in my binary representation, it will run till 6 times. So simply we can say that my time complexity will be big O of total number of ones present in its binary representation. So this was the most simplest question. I hope so you understood this video clearly. Just in case if you are new to the Runtime Error, please do hit the subscribe button, which motivates me to create such content for you. Till then, have a happy coding.